Today we are going to start with functions. Nobody's clapping. Okay, functions. We're going to start with functions, and I'm going to tell you that I put the fun in functions. Okay, thank you. That was fun. That was good. Very good. That fake laughter that you get on those sitcoms. I think it's awesome. Okay, so what we're going to do today is we're going to discover how do we figure out if something is indeed a function, when is it not a function, and then more specifically, what kind of function is it? That's exciting stuff. And then we're going to draw them a little bit to kind of get a feel for them. We're also going to learn how to, and it may not all be today, how to compose functions, composition, which I know you guys have done before. And then we're going to find inverses of functions. And to wrap it all in a nice little bow, we're going to talk about domain and range. That's where everybody starts to boo me. But I get it. We'll get there. Okay, so functions. We're going to talk first about what indeed a function is. So when I'm looking at visually, verbally what a function is, I typically say that every x value is going to produce a y value. Okay? And we're going to get more specific as I kind of talk about yes and function, not a function. So every x value will produce, and I guess I should probably say, well, no, I won't go that far yet. So every x value will produce a singleton y value for what we're talking about now. So if I'm looking at this and I want to start to draw, okay, and I draw a straight line. We want to look at it visually and say, okay, is this indeed a function? So does every x value produce a y value? Yeah, so this guy over here would produce this point on the line, this guy would be this line, and et cetera, et cetera. Is everybody feeling it so far? Okay, so it is indeed a function. Visually, you can look at this, not know the x and y values that are produced from it, and know that it's a function because we have something called a vertical line test. Have you ever heard of that? Vertical line test? It's been a minute. Oh, vertical line test is geometry. Yeah? No. Yes. Maybe. Yeah. What's a vertical line look like? Do it with your hands. Yeah? I don't have anybody trying to give me a horizon, right? I have vertical, right? Not horizontal, but vertical, right? So take this beautiful line and draw an infinite number of vertical lines through it. Bless you.
Good morning.
We are doing the vertical line test. Indeed is a function because my vertical lines only hit that line only once, which is great. So let's look at the next visual. Let's say we have y equals x squared. Okay. Do you guys see my visual here? Okay, I'll turn on the lights when he tells us it's okay, but here we have a parabola. So the question I ask you, is it indeed a function or not? So if I take every x value, so let's kind of come up with a table. If I had negative 1, 0, 1, and 2, and I was plugging it in, what is negative 1 squared? 1, good. What is 0 squared?
0.
And then 1 squared?
1.
And then 2 squared?
4.
So the question I ask you, is it okay for these x values, negative 1 produce a 1, 0 to produce a 0, 1 to produce a 1, and 2 to produce a 4. Is that okay? Well, indeed it is. So if I'm looking at this, it is okay for every single individual x value, only have the x values displayed once for each one, they produce a y value. Doesn't matter if it's a duplicate y value. So let's go ahead and look at it visually as the vertical line test happens. If I was to draw straight down like that, do I have a function? Indeed I do, because I've only hit that thing, infinite number of vertical lines I could draw, would only hit it once. Are we good so far? Okay, now, the next example,
Would be a circle.
not quite, is something like this. But I could say a circle would do the same concept. It's a sideways parabola, okay? Do you guys know the formula that would be for what this guy here? No? Yes? Do you think you know? Go ahead.
Isn't it x equals y squared?
Exactly right. x equals y squared. Beautiful. And so x equals y squared would be this guy here. So if I'm looking at this, each of these x values, if I'm looking at x values, do you agree with me that this x value produces this guy here and this guy here? This x value produces this guy here and this guy here? That's a no-go, okay? Because each of those x values produce. So if I draw my vertical line, I hit it twice, and that's a no. So in the real world, are they always going to give me visual pictures of my graphs to say, yeah, no? So let's look at it as ordered pairs. And I'm going to bring a real world situation into play for this one. Okay? So we have x and we have y. I'm going to label the x column as girls and the y column as boys, just for the sake of labeling them, okay? And I'm going to tell you the names of x are going to be 1, 2, 3, 4, and 5. So the girls' parents were very, very clever. 1, 2, 3, 4, 5. The boys' names are A, B, C, D, and E. Okay, very cool names as well. So, if, and this is a dating thing, so if girl number 1 dates boy A and 2B and 3C, etc., is this what we consider a function?
Yes.
Because every x value has a y value, okay? Okay, so we're good so far, right? Very cool? All right. So we're going to go with the same scenario, the same people. And we're going to talk a little bit about, well, let's just go this route. I'm going to have 1 is dating boy A, and 2 is dating boy A. And what do we call this?
Cheating.
You say not a function, we say cheating. Some people call it player. I don't even know what's going on. So, playa. Okay, so what do we call it really? It's actually indeed a function, okay? Because think about your parabola. The number 1 produced a 1, and the number -1 produced a 1 as well. Was that okay? So every x value can have a y value as long as the x values are singleton. Did that make sense? So indeed, it is a function. Okay, the last scenario, and you know where I'm going with this one. Okay. What do you call that?
Oh.
So I know what you all want to call that. But we're going to call it, just for the niceties, we're going to call it not a function, okay? So you know who that person is in the hallway. You remember that person, not a function. And you'll know what it means, all right? So, definitely not a function. So girl number 1 cannot date boy A and date boy B at the same time. Now, why in the heck would you want to date 2 boys? Never mind. So the idea is you can't have a singleton x value with 2 different y values. Think about your sideways parabola. The number 1 produced this, and that was a no-go. So if you're thinking about it visually as far as ordered pairs, if your x value produces 2 different y values, it is not a function, okay? So now you all have a name for that, all right? Right? You never know. Let me just say, you are not a function, and they will never know what you mean. So there we go. All right, so thinking about that aspect of it, if I tell you I'm having fruit for a snack, don't you kind of want to know what kind of fruit I'm having? Does that make sense? Like if I say I'm having fruit, you're thinking, is she eating a banana? Or is she going to have a strawberry? You know what I mean? So fruit has categories underneath. Functions, just like fruit, have categories underneath. There are multiple types of functions. We're going to specifically look at one in particular, but its pair that kind of goes with it. So there are the types of functions that we're going to look at right right now, the ones that I'm gonna really focus in on, is a one-to-one function, okay? One-to-one. This right here often comes in as a singleton Cambridge question, typically worth a point or two. And let me tell you what, if you remember that verbiage, one-to-one, you pull that point. Remember, you only need, in the past, you only needed about 45 points to earn college credit in this class. Last year, they needed 27 points. If you could get a point from knowing this word, more power to you, right? Every point counts. So one-to-one, if I'm talking about it in like layman's terms, somebody that's not a mathematician, again, somebody like me, if I'm looking at one-to-one, it means that every single x value produces a y value, a separate different y value. So a separate different y value, okay? So every single x value has its own producing. But if I'm looking at it, because I feel if I look at it visually, like I did with the parabola and the straight line and the sideways parabola, if I think about it visually, it makes great sense. The way I like to describe this is the graph is going in one direction, okay? When you learn how to read a book, read a paragraph, read something, does it make sense, you don't even think about it now, that you read from left to right? You take your eyes to the left and you scan it to the right. Does that make sense what I just said? The same thing happens with a graph. If you're reading a graph, you actually are reading it from left to right. So if I'm looking at this graph, okay, and I start from the left, where am I going to start? Here, right? And then tell me verbally, describing it to me, say I don't know what it looks like, tell me what's happening to this graph. It's going where? Up. Going up, and then continuing to go up, and then what's happening? It's still going up, and again, going up. Does it make sense that it's continuously going in one direction, which is up? It is considered one-to-one. A one-to-one graph goes in one direction. Each of these x values are going to produce a singleton y value that's totally different than the last one you produced. Does that visually make sense? What about something like this guy? One-to-one?
Yeah,
Why?
because it's going in one direction.
Go in one direction. In other words, going down. Very cool, right? How about this guy?
No.
That's a pretty parabola. So what is it? Read it from left to right. Visually and verbally tell me what's happening.
It's going down and then it goes back up.
And then it goes back up. It goes down and then back up. Does it go in one direction?
No.
Nope, because it goes down and then it goes back up, right? Not going in one direction, not one-to-one. It's actually got a name. We never use this name. This guy we use all the time. This guy we really never use. It's called a many-one. Many-one function. I know, weird. I don't use it. I have a degree in math and a master's in it, and never did I ever use that. So, you know, many-one, whatever. Okay? So, many-one meaning it doesn't go in one direction. It goes in many one directions, I guess. So, it is definitely a function. Yes? A function? Do you guys agree it's a function?
Yes.
Yes, it's a function. However, it's not a one-to-one function. So, this brings me to talk about the most exciting part. I say that with reservations because it's really not the most exciting part. I say that we have to talk about domain and range. A lot of times teachers just kind of skirt over domain and range because it's whatever, not as fun as it could be. But I think I can make it okay. So, I started this lesson by telling you that to describe a graph, you read it from left to right. You guys cool with what I just said? So, when I'm looking at this thing, and I know I have a parabola here, what do you know about a parabola? A parabola goes in this direction forever and a day, right? It never stops. Do you guys agree with me? A parabola, we know, we just have a snippet of it, but it'll go on forever. So if I'm reading this, when I'm talking about domain, what variable am I referring to with domains? My x values. So literally I'm saying, if I start reading this graph from the left, in the x range, the x values, and I read it to the right, what's happening visually to my x values. So my x values are going to start way over here, continue, even though it kind of slumps down in the y range, it continues to go over here forever and a day. So what are the values of x that'll make this thing work? Okay, so do you agree that every value of x is going to eventually be on that particular graph? Because it's going this way that many, and it's going this way that many. Are you guys cool? So what is the domain? The domain is everything, all real numbers. So that's one way most teachers describe it. X is an element of the reals. That's typically how books give it to you. X is an element of any single real that you pick. Do you guys know what real numbers are? Are we good with reals? Integers. Keep going. Are fractions reals?
No.
Yes, they are. Is 1/2 a real number? 0.5?
Yes.
Yeah, we're good, right? 0.5 is good. So truly, things that are things that are real is pretty much everything. Every decimal you can think of, they're all in that real range. When it becomes something that's not real, they are imaginary, which we're not doing this year, okay? So real numbers, anything you choose will be on this graph. Fraction, decimal, whole numbers, positives, negatives, we got them, okay? Another way to write that for this, knowing that it goes forever, is it can go from negative infinity to infinity. When I put parentheses around those things, that means I am going to go to them but not include them. So can I ever equal infinity? No, it's not even an option. So that's why I use parentheses. Parentheses says to me, we're going as far as we can to it, but we're never going to meet it, okay? The other last way that we can do this thing is that we would take and write it like negative infinity is less than x is less than infinity. These are 3 different ways for me to tell you the domain of that parabola. Are you cool so far? Yeah. Okay, so domain, like reading a book, starts on the left and works its way to the right, okay? Range, however, is talking about how high and low does that graph go. So I'm talking about up and down. So visually I have to look at it. Is it going, typically I can start reading it from the bottom of the barrel on up or the top of the barrel on down. Does that make sense? So I'm looking at this, do you guys agree with me? It bottoms out right here. So what is, if this picture was a pretty bad depiction of y equals x squared, but what is my lowest low on this particular graph?
0.
0, right? Does it include 0? Well, not by my picture, but if this is indeed y equals x squared, does it include 0?
Yes.
Sure does, okay? So how can I write my range? Now remember, domain are x's, ranges are y's.
Y is equal,
Go ahead.
Y is equal or greater than 0.
Y is greater than or equal to 0. Perfect. Does it include 0? Sure does. Okay, and then everything above it works. Let me give you another way to write it, okay? I'm going to include 0, and then I'm going to go towards infinity. Oh, do you see what I mean, what I did differently?
Wait, the bracket means include it.
Exactly right. The bracket means I include it, and the parenthesis means not including. Do you guys see the difference up here? Including, and then I can never touch infinity. Okay? Last way I could write this is I'm going to go 0 is less than or equal to y is less than infinity. That's yet another way for me to say, this is the range of that thing. You choose which one you like best. Are we cool? So far so good? Feeling good? You know what, and if you guys are taking the SAT or the PSAT in the upcoming weeks, this right here is a really cool opportunity. I hope you guys sign up. The PSAT for juniors is the only way that you can get national merits. So this is the one that you really want to kind of do. All right, are we feeling good? All right, let's do this. Okay. what was this thing before it became to this format? What was, I mean, it's a trinomial, would you agree? And what did they do to get it to look like this? They did what? They completed the square like we did yesterday, right? So if I give you a trinomial and I want you to tell me the domain and range, you really want to get it into this format. This format is the key. It's the key to drawing it easier, and it's the key to be able to visualize what's happening pretty easy, okay? So the first thing I ask you is it is a parabola opening up or down? Up. Why do we know that? Because whatever's in front of x squared is positive, indeed. And then what is my actual vertex? Positive 3, and then negative 2. Okay, so I'm going to go over to 3, down 2, put a dot, and then open this puppy up. I really don't care if it's beautiful, it's just going to look like that. Okay, I'd like you to write the domain of this, and I'd like you to try your hand at finding the range of it as well. I know, throw you in, just like that. Your domain and your range. Your domain is all real numbers. How'd y'all choose to do it? X is an element of the R? Yeah, most people like that one best. Okay, and then what about this guy? Y is greater than or equal to? Negative 2. Yay, yes.
Is it required that we use like the same kind of, or you have them not